So the way applications are built now, developers try to divide this application into different services. So we call those microservices. You can take a note of that, microservices. So let's use your banking app as an example. The login part is one service. The part that will do the checks and balances of your application of your account is another service. The part that would retrieve your account details is another service. These are small components that make up the application. But if one part goes down, in the current way we do it, if one part goes down, that means everything goes down. If the data layer goes down, that means everything goes down. So that's why applications these days are built into microservices. So that even if one part has a problem, you can always restore that part while the other parts are still alive. All right, so one of the main applications that helps us to achieve this level of reliability is called Kubernetes. Kubernetes is so popular around the world. It's a really hot topic now. If you can get the gist of Kubernetes, and even if today you can get the gist of Kubernetes and even get excited to dig deeper into it, I'm telling you, you are going to have a very beautiful career. Next slide. So what exactly is Kubernetes? Kubernetes is a production-grade container orchestration system. It was built with lessons from Google's large-scale infrastructure platform called BALOGUN. Kubernetes was designed from the ground up using the Go programming language, and its components are loosely coupled. So like I said, it's a production-grade container orchestration system. It's a system that helps you to orchestrate containers. A container, you can think of a container as a service. This is just me being reducing what it is, but basically you can look at a container like a service. So imagine we are hosting thousands of services. You as a human being, you can't go and be managing it of them. Maybe one of them, the file system is full. Another one, the server has gone down. Another one, the networking is not working properly. You need an orchestration system, something that is at the helm of the ship, that helps you to control this large scale deployment. So that's where Kubernetes comes in. You guys will know that, or it's interesting to know that Google that the Google we access every day is one of the largest infrastructure platforms in the world, right? It's a very large system because thousands and thousands of people are accessing Google every day, and every time you click on Google, it responds to you. Every time you open Google Maps, it responds to you. It's always alive, So the reason it's alive like this is because of this platform that they have, this BALOGUN platform, which is what Kubernetes was now built out of. All right. Again, Kubernetes was designed from the ground up using the Go programming language. This is important for you to note. So if you are going to go into Kubernetes development or Kubernetes advanced support, you probably want to learn the Go programming language. Go programming or Golang, it's a very interesting programming language. It's a sequential language. So if you are used to Python, if you're already used to Python, you'll be, you just flow quickly with Go programming language. So for your scripting, all those kind of stuff, just add Go programming language to your list of tech stacks. You really enjoy it. All right, next slide. You have one server that is hosting your database. You have another server that is hosting your application. And this server, they can be VMs like virtual machines, or they could be bare metal servers. Bare metal servers are actual servers, the hard servers that we put on a rack in the data center, right? And then or storage. But Kubernetes helps us to put a layer of abstraction above the hardware. So you are no longer interfacing with the hardware directly anymore. Now you have a layer of abstraction that helps you to manage the underlying hardware under. You know, it provides a singular interface where services and workloads can be deployed and managed. This is very important. It provides a singular interface. That means from my Kubernetes CLI, I'm able to manage my full stack of services in that cluster. I can deploy, I can manage it, I can upgrade it. If you are, let's say you're using Access Bank now, and then they've done an update on the Access Bank app. Kubernetes will allow you to quickly do a deployment, to do an upgrade without users even experiencing any downtime. There are many styles of deployments, or many styles of upgrade. You might want to note this down also. It will help you when you're going for your interviews. There are many types of upgrades. There is the blue-green approach. There is the canary approach. There is the total. You just put off all the old servers or the old services and bring out the new one. There are many types of approach, that you can use for application deployment or application upgrades. Kubernetes gives you the leeway to create or to schedule upgrades the way you like. So the next is Kubernetes is also a scheduler, which means it brokers a treaty between the current state of a service and the desired state. This is also very important. Kubernetes helps you to, for example, I can tell you this from professional experience, that any application that you are working on, or that you are using, especially an internet-facing application, that is an application that is not running on your system. Let's say you are accessing Facebook, or you're accessing your banking apps, or you're accessing Twitter or Instagram. It takes a lot of effort to keep those systems alive. The default of the system is not to stay alive. The default of the system is always to must have noticed a lot of downtime these days. Sometimes in Facebook, Facebook had a major downtime last year where we couldn't access WhatsApp and Instagram. Our banking apps in Nigeria, they have those kind of problems every other day. So the default of the system is not to stay up. However, Kubernetes as a scheduler, it helps us to broker a treaty. So Kubernetes has a way of checking the current state of the system and then comparing it to the desired state. What I mean by desired state is, for example, if I say in my database now, I want it to, or let me say for my application, I want it to be a four pod application. At every time I want this application to have 4 containers. Maybe I want one container to serve the people in Lagos. I want another container to serve the people in Ogun State. Another container to serve the people in Kano. For any reason, if one of the containers goes down, Kubernetes is intelligent enough to help you to restart it. It checks what has my administrator said I should have, and what is the current state. It helps you to broker a treaty between it consistently. So as an engineer, you don't have to spend hours on hours on the system. Once you have configured Kubernetes correctly, it helps you to do many of these tasks, of keeping the system alive. All right, let's go to my next slide. Like I said, if you have any question, please just post it in the group chat. I'll be very happy to take it. Next slide. Kubernetes is built for reliability. I've spoken about this a little, but let me just talk more about this. Kubernetes is self-healing. At the beginning of this slide, I told you that Kubernetes is built loosely coupled. It's not like our bare metal server where we have, disks inside the server, and then if any of those disks fail, it means that the whole system has failed. Kubernetes is loosely coupled. If the way it's designed, it's a way of thinking. If the way it's designed, if a particular service goes, if a storage goes down, it's easy to quickly recreate another one automatically and attach it back. So it's self-healing. Once you start playing with Kubernetes, you will be so amazed. It helps you to create. It seems like it's alive. one part of it goes down, it recreates it immediately. It's such a powerful platform. It continues to monitor the state of the services. If one pod goes down, it quickly recreates another one based on the number assigned by the administrator or the developer. Okay, so next slide. Next slide. All right, very good. So this is just a graphic showing you what Kubernetes looks like. I told you that, and some of the components that make up Kubernetes. I told you at the start of this presentation that Kubernetes means helmsman. That's why when you see the Kubernetes logo, you see the helm of a ship. That's the steering wheel of a ship, right? But for Kubernetes to do this, it needs some components. There are some basic components it needs that helps it to do all this magic. We call these components the control plane. So there are some services, there are some programs that are running on Kubernetes master, that helps it to perform all these tasks that we've spoken about. And the basic architecture of Kubernetes is there is a master node, which is this big ship you are seeing here. There's a master node, then there are worker nodes. You can have hundreds of worker nodes, just as actually there's a particular number I think is about maybe 1,200 worker nodes. Somebody can help us to Google that, but basically you can have hundreds of worker nodes connected to one master. This quorum or this cluster forms a Kubernetes cluster. It forms a Kubernetes cluster. You have the master and then you have the workers. So the master has some components on the control plane that helps it to do this work. One of them is the Kube API server. We'll talk about this in the next slide. The Kube API server, we have the control manager. These are services. We have the etcd cluster. We have the Kube scheduler. These are just some of the components that run on the master node. Then on the worker node, we have the Kube proxy, and then we have the kubelet. So I don't want to go too deep into this. If you have specific questions, please you can ask. But this is just the basic architecture of Kubernetes. Next slide, please. All right, next slide, please. All right, Kubernetes architecture. Like I told you in the first slide, Kubernetes has the master, right? It has the master node. This node is you can think of it like a server. It's like a server on its own. Then it has a worker node. On the master node we have an etcd. Etcd is a database. We'll talk about this in the next slide. We have etcd. These are the major components of the master. We have the etcd, we have the Kube API server, we have the Kube controller manager, we have the Kube scheduler. Then on the worker node, we have the kubelets, we have the Kube proxy, and then we have the container runtime engine, which is the CRI. Some of these things are open source, right? They are not built. They are just, that's why I told you it's loosely coupled. Many things are just brought together, like the etcd cluster is a separate project on its own. It's a database, and then the container runtime engine, the CRI, it's a separate component on its own, right? So some of these things we just pull them together, and this is what makes up Kubernetes. Next slide, please. Okay, so this one now we're going to talk about the master components. The master components of Kubernetes. We have the etcd. Like I told you, etcd, very interesting. Etcd is a database. It's a key value database. It's free. You can download it right now. Etcd is a key value database. It helps us to provide a strong and consistent, highly available key value store used for persistent cluster states. when I say key value store, somebody sharing their screen. Okay, all right. All right. Thank you, media team. So next we're talking about etcd. So etcd, like I said, um is the brain. Let me not say the brain, but is the heart of Kubernetes. This is where the current state of Kubernetes is stored. It's very important. It's a core process needed for the stability of your Kubernetes cluster. Then we have the Kube API server. For those of you that are developers, you know a lot about API. So the Kube API server of Kubernetes allows us to, receive API requests via a standard REST interface. This is how the kubelet connects to the connect. This is how the worker node connects to the master node. Let's not get too complicated, but just the basics of it. While the kube controller manager. The kube controller manager is a primary daemon that manages all core components and the control loop. So this is what helps us to control the state of the cluster. Then we have the kube scheduler. The kube scheduler is a verbose, policy-rich engine that evaluates workload requirements and attempts to place it on a matching resource. So, like I told you at the start of this presentation, Kubernetes helps you to schedule. It helps you to schedule, and what the component that actually helps you to do this scheduling is the kube scheduler. So it helps you to schedule. It helps you to check what are the requirements that you've set out, and then what is the current state of the application. So the kube scheduler is always checking and always updating. Next slide. So now let's talk about setting up your Kubernetes cluster. I would like as many of you that are interested in this to please take note of this. I want you to, if possible, take this seriously. I'm in the market now, so I can tell you what the market is saying. Kubernetes, as a Kubernetes developer or a Kubernetes administrator, you would not be out of job for a couple of years. It's a very interesting place now. There are lots of companies that are looking for Kubernetes engineers that are good at Kubernetes, right? The important thing that makes Kubernetes so interesting is that it's free. All these things I'm telling you now, you can download it on your laptop this night and start practicing with it. You're not going to pay a single dime. All you need to start running Kubernetes is knowledge, right? So that's why a lot of companies are also going for it, because it's free. Before now, if we're going to run something as complicated and as reliable as this, you have to pay millions and millions of dollars, as a company. But now, and even as an engineer, you have to have read and read and read before you can manage that kind of thing. But Kubernetes, everything is free. This is the beauty of open source. You can log in now and download the full Kubernetes on your system and be practicing with it. By the time you graduate, you're already an engineer. You're already good at it, able to get a good job. So the basics of setting up a kube ADM or setting up Kubernetes on your system. Number one, you probably want to use a Linux machine, right? You can run Kubernetes on Windows, but for most production grade Kubernetes, right? For most production grade, when I say production, I mean something that is being accessed by the general public, right? So for most production grade Kubernetes deployment, it's mostly on Linux that they deploy Kubernetes, which is why it's also important for you to level up your Linux skills. I'm going to talk about Linux later on in this chat, right? So we have an application, we have a small deployment called Kube ADM or Kube Admin, right? You can just take note of it. Kube Admin helps you to create Kubernetes on your system. So the first step is to set up your Linux machine. Second step, install Kube ADM. This is the command to just copy it and paste this. You install Kube ADM. You can it will help you to create your control plane, and after that you can go to your worker node and then install KubeADM there, and also install your Kubernetes kubelets on those worker nodes. That's just the basics of setting up a Kubernetes cluster. I've given you some of my how you can reach me. Okay, so if you start on this journey, you are ever experiencing any challenge, feel free to reach out to me at any time. Just send me a mail, send me a message. Be clear with your message, okay, so that I can come in and help you. Next slide, please. This next slide now, I'm going to talk about how to contribute and how to innovate. Kubernetes is free. I've said that already. It's open source. It's free, so you can download it now and start working with it. However, some people are working on it day and night. That's why we're able to access it. That's why we're able to use it. It's because some intelligent people are working on the source code for this Kubernetes every day. They are updating stuff on it. So the way we contribute to Kubernetes is we have special interest groups. Okay, they call them SIGs, special interest groups. When I say special, this is like, you can imagine like a WhatsApp group. So it's like a WhatsApp group of some people who are interested in API machinery, right? There are some people that are just interested in storage. There are some people that are interested in networks, right? Let me go to this slide myself, okay, so I can see properly. Okay, so as I was saying, some people are interested in networking. Maybe they are network engineers in their current field or in their place of work. So they have a large understanding of networking. So they can come into the contributory space and then contribute their knowledge to Kubernetes, to a Kubernetes project. So a way to contribute and a way to innovate is to join a SIG, right? If you get interested in this, you have a basic understanding of programming. You have learned Python, you have learned Go. You don't even have to know only Go programming language. Different kind of programming language that even if it's Java, and you are interested in contributing to Kubernetes or interested in the ecosystem of Kubernetes, you join a SIG. You choose there are many SIGs. There is the SIG for UI, like the interface for Kubernetes. There is the SIG for multi-clustering, the SIG for authentication. Many types of SIGs. Anyone that sparks your fancy, right? You pick that one and then you work with it. And then you join the SIG. You listen to their conversations. You listen to what they're talking about. Then slowly you can start to contribute. You might not even have technical skills. That I mean that to say, like, you might not be a code developer, right? You might just be good at writing. There is a place for you also. Kubernetes has a large it has a large documentation. So you could be part of the people that contribute to the Kubernetes documentation. I will show you a link to the Kubernetes documentation later. So this is how you innovate. This is how you become part of a global ecosystem, right? Even from your comfort, from your room in Nigeria, you can be playing on the international scale. This is how to do it. Next slide. So now the community links. So you listen to this presentation now, you are fired up, you are gingered. You want to take your Kubernetes journey to the next step. Try and join some of the communities, right? Some of you, I'm sure a lot of you are already familiar with how developer communities and communities generally are. Download Slack. Slack is an application. Download Slack. Join the Kubernetes Slack. That's where everybody that is interested in this project is talking about it. You can join the GitHub on the GitHub for Kubernetes. You can see how people are posting, the PR requests people are putting, how people are discussing about the project. This is how you get involved in it. You can join the special interest group. Some of this, I'm a part of the networking special interest group, but there are many hundreds of special interest groups that you can join. There are even sub projects. So you find one that you're excited about and then you join it. Most of the special interest groups, they meet once in a week. It might not be too comfortable for our time zone because they meet, most of them are in America, obviously. So it might not be too comfortable for our time zone, but it's also a sacrifice you have to make. You wake up in the night and you join it, or you watch it later on YouTube. Okay, so these are some other what do you call it? These are some other these links. I think your administrator has already shared it, so you can always check these links out. Okay, next slide, please. All right, so that's the basics of Kubernetes. Let's talk about Linux for a bit now. Linux is very deep, Linux is very expansive, but let's see where we can go. This is just to spark your interest. Excuse me. So, or you know what? Do we have some questions on Kubernetes before I go into Linux? Let me check. Um, let me check some of the questions. Chat. Okay, I can see. If you have any questions, please, this is a good time to just put on your mic and ask, okay? All right, let me go to the chat. Okay, do we have any question? Okay.
Yes, sir. I think I have a question, sir.
All right, please.
This is Blessing Efia. Please, my question is that I'm interested in the Kubernetes, but after installing the software or app in my system, what are the basic steps I need to take?
Okay, that's a good question. So once you download can you put up your mic?
I should put on my
Put
off
up
my
your
mic.
yes. All right, because it's echoing. All right, so once you've downloaded Kubernetes and it's running successfully in your system, you can start to there are some free services that are online. There are many of them like NGNX. That's a load balancer. You can take note of these things I'm saying so that you can Google it later. There's NGNX. There is Redash. There is Postgres, the database. All these are free. They are open source. They are free. So once you set up your Kubernetes cluster, you can easily pull these images to your system and start practicing with it. But the main thing you should focus on first is to even get Kubernetes running on your system. That alone is a good achievement as a first start. Another advice I will give you if you are really interested in this is um, um, try and sit for the certified Kubernetes administrator exam. Okay, you might not have the money yet to pay for it, you might not have the resources to pay for it yet, but follow the track, right? Follow the learning track. You can just check about CKA. There is just like how your exams now in university, you have a curriculum, right? The same thing with CKA, certified Kubernetes administrator exam. There is a curriculum, so you can follow that curriculum one by one on YouTube on the Kubernetes.io. That's the documentation site. You can follow it. You check a topic. Maybe the first topic they say introduction to Kubernetes. You go to YouTube. You read about it. You go to the documentation. You read about it. That's how you can become good at this. Does that answer your question?
Yes, sir. Please, you are talking about how we can contact you if you have any challenge, but I've checked through the chat. I've not seen something like email address or your social media handle.
Okay, it's on the slide. I don't know if I'm going to make the slides available.
I don't get that from the slide. Before I come, they very past that slide.
Or you pause the slide.
Yes, sir.
Administrator, is the slide going to be available?
No, the slide will be available.
Okay.
Yeah. I mean, can you share it? All right. Excellent. Excellent. Thank you very much. All right. So now let's go. Okay, next. Is there any other question? Any other question? Um,
I have a question.
All right, please.
Okay, my name is Steven Nagos, now the chapter president. I would like to know, Linux, is it, does it, sorry, can Kubernetes run on Windows or maybe Apple as iOS? So it is just strictly Linux. Okay, because when I saw the installation, this thing you put, which I saw on the slide, I know that seems more of Linux, because I know how Linux is. I'm familiar with the operating system.
Thank you. That's a very good question, Steven. Thank you. Um, Kubernetes can run on Windows. You can run on your Mac OS, right? Maybe you just want to use it for testing. You can run on Windows. There is this application called Minikube. You can take note of that. Minikube. Minikube helps you to set up a small Kubernetes cluster very quickly. There's another application called Kind. You can just type and write that down. Kind or kindness. It helps you to also spin up a Kubernetes cluster. However, I don't want you guys to run away from Linux. If you're ever going to come into the developer space now, you're going to come into the site reliability space, or the ecosystem right now, you are going to have to learn Linux. So it's even better if you start working with it from your lab environment. So in this chat about Linux, I'm going to show you how you can set up a Linux system on your Windows machine. Okay, I can show you how you can set up a Linux machine so that you can start to practice. You can start to practice some of these things. But however, you can actually set up Kubernetes on Windows and on macOS. Is there any other question? All right, thank you very much. So now let's go into Linux. Introduction to Linux. So it's fundamental. Everything I'm talking about today is free. I like free things, so that's why I'm really into open source. Everything I'm talking about today, you can download it now and start working with it. You don't need license, you don't need to pay anybody. All you need is your internet. You download it and start working with it now. So at its fundamental, the Linux kernel is a program that allocates and controls hardware resources of the system. Linux is an implementation of the Unix kernel, which was developed by Bell Labs. This was many years ago, maybe 1960 something. That's when they created Unix. So this is an operating system, just like how we have Windows operating system, which most of you use, or Android operating system, which we run on our phones, or iOS that we run on our handheld iPhone devices. Unix is a operating system that is run on servers. It's very stable. That's why it's used in banks. It's used in places that need a lot of reliability. You don't see them using Windows. They would like to use Unix or Linux. Because it's very stable. It's very engineering friendly. So it's a very stable environment. That's why most people, or most big organizations, they tend to use Linux for their server operations. Okay. Linux was, I want you guys to take note of this also. Linux was created by a 21-year-old called Linus Torvalds in 1991. So this Linux operating system, which we are all using now, Linux is one of the most popular, if it's not the most popular operating system itself. It's so powerful. You find Linux everywhere. For Windows now, the only place you can find a Windows operating system is maybe on your Windows, is on your computer, or those kind of things. But Linux is everywhere. The Android that we're using, it's a fork of Linux. Some of these new cars, it's Linux operating system that they are running. Thermostats, all these small devices, and all these small devices that require a level of operating system. It's mostly Linux that they use. Why? Because Linux is free. Linux is small. You can deploy it on. I don't know if some of you work on Raspberry Pi, right? These are small computers, very little computer. Can you hear me? Yeah, thank you very much. Raspberry Pi, thank you. So Raspberry Pi is just a very small computer. You can deploy Linux on it and start working. You start working on it. That's the beauty of Linux. It's not like some of the other operating systems that are bogus and have GUI and have some other unnecessary things. Linux is just straight to the point, and it's easy. It's very easy. Once you're comfortable with it, it gets easy for you. And I'm also saying this because I don't want you to. Because when I even started my own career too, I was afraid of Linux. I was afraid of going into Linux. It took a bit of encouragement for me to get into Linux. But when I got really encouraged, I realized that the person that wrote Linux was a 21-year-old. He's just a young guy. He's the one that wrote the operating system. You know, a very smart guy in Finland. He's still the one that operates it up to now. I think he will be 50 something years old right now. You know, so if a 21-year-old could write the whole operating system, that means I should be able to learn it. You know, I should be able to learn. I should be able to work on it. It shouldn't be that hard. You know, so I'm not saying this to get you guys excited about this ecosystem. You know, get your hands dirty. I'll go to in the next slide. I'm going to show you how to download Linux, how to start working with it. Next slide. So again, why Linux? Linux is free. Like I said, it's free. You can download it right now and start working on it. There are many. I want you to take note of this also. There are many distributions. We call them distributions of Linux, right? There's a core of it, which is maybe the Unix. You know, but then different people, because it's free, different people can customize it to what they want. Different people can, when you customize it, we call it a fork of Linux, which is just like a fork, an angle out of Linux, right? So different people have taken forks of their own, they've customized, made some changes to it, and a lot of them are free. So today, if you open, you can also go to CentOS. For example, if you type CentOS, CentOS is a free Unix distribution that you can download right now and start working on it. CentOS is, I would advise you, if you're actually going into this, I would advise you to use CentOS, right? CentOS is very similar to Red Hat Enterprise Linux. Red Hat Enterprise Linux is not free. That one is not free actually, but CentOS is a direct replica of it. You know, Red Hat Enterprise Linux is not free because the company provides support for it. You know, but CentOS itself, that one is free and it's the same thing. Right, so you download it to your laptop, you start playing with it one by one, small, start to get the hang of it. You watch videos about it. You know, you can try and take the Red Hat certified administrator exam, even if you don't have the money for it. Right, you look at this is what I always advise the younger engineers that are working with me. You take the course content, right, for the Red Hat certified systems administrator exam. Sorry. You take the course content, right, and then you start to work on it one topic at a time. Maybe one night you take one topic, another night you take another topic. That's how you become good. Okay. Another reason why it's good to get into Linux is because Linux has a very large community. So any problem that you've had, I can assure you that 10,000 people have had that problem. Okay, 1,000 people have had that problem. You know, so once you Google it, you will see resources for that problem. So that's why Linux is. That's another reason why Linux is very good. All right, next slide. So now I want to teach you about getting started with Linux, and for this one, I think I might want to share my screen if I still have time, so I can just walk you through. All right, let me share my screen. So, first of all, let me go back to that slide. All right, can you see my screen?
Yes.
Right. Thank you. So, for you to get started with Linux, there are some basic things you need. Your president has told me already that you are familiar with Raspberry Pi. If you have Raspberry Pi, that is a good place to start. But if you don't have, okay, not all, but okay, that's fine. That's fine. Even if you don't have access to a Raspberry Pi, you can set it up on your system. If you have a computer, right? Even if you just a small computer, you can set it up on your system. This is how you set it up. Your step one: you download a virtualizer, a virtual machine, or a virtual machine manager, right? I've listed out a couple of them for you. Number one, we have the Oracle VirtualBox. It's free also. So if you're using a Windows or you're using a Mac, and many of you are already familiar with this, but for the sake of those that are not familiar, let me just go through this. If you're using a Windows or a Mac, you can download Oracle VirtualBox for free, and you can spin up a Linux environment there. So you have your own operating system. You can just spin up a virtual machine that is running on your own system, easy to practice. For those of you that are running on Windows, you can set up Windows Hyper-V Manager. That's Hyper Virtualization Manager. I would advise you to also get familiar with this application. I'm going to show you this application now. It's a lot of organizations are also using it. The next one is Parallels Desktop. Parallels Desktop is not free. but it's very stable, it's very beautiful. You know, it's a fine design that they've done with it. So if you have the money, you can go and download Pilot's desktop. Me, I don't have the money, so I go for free things. Then there is UTM. UTM is for Mac, it's free for Mac. So you know, UTM is also a good place to, it's also a good one to work with. Next I'm going to talk about now is, I've already told about the OS. So we can just go to Google directly. Let me even just open it directly and show you. Let me open Google Chrome tab here. New window. Draw this. Right. So just say download CentOS 8. Can you guys see my screen? Hello. Alright guys, my screen. Awesome. So download CentOS 8. I just typed that on Google. I'm already there. Download CentOS 8. It takes me straight to the download site. You know. Let me just show this to you so that you don't make a mistake when you are going forward for it. You just come here, then you choose the architecture of the system. If you are using Windows, then you are most likely using the times 86/64. If you are using a Mac OS, the new Mac OS, the M1, it's ARM, so you can choose this one. But for most of us, it's probably this one we're going to use. So you just click on it. It will take you to a link here. All these links here are mirrors, right? They take you to the same resource, but some of them are closer to you than others. So you can really just click on any of them. I'm just going to click on the first one, and then it opens an FTP server of the files. So you just click on this one, the DVD ISO. The file is about 10 gigabytes. You know, so this one is quite heavy, but you can download it. Just download it to your system. In fact, once I click on it, you know, download starts immediately. Right. So this is something good. When you have free internet, maybe you go to airport or you go to your university library where there is free internet, and here you can just download it and let it run overnight. So once you do this, you've gotten the IS on your system. The next step is to open Hyper-V Manager. I've told you already that if you're using a Windows system, you already have access to Hyper-V Manager, right? So I think setting up Hyper-V Manager is, let's close this guy. So there's something called program and features. Let me show you. If I use a Windows machine, Windows features, yes. So Windows features. This is where you can just turn on or turn off some Windows features. These are some things that come with your system, but you can turn it on or turn it off. It's like extra programs, you know. Okay, so this is it. This is Windows features. You can see I've already installed Hyper-V here. But if you haven't installed it, all you have to do is just click on it, and then once you press OK, it will install the feature. And then after you restart the system, the program will be available to you. So once you have the program installed, you can just type Hyper-V, the search box. It brings out the application Hyper-V Manager. This is another free virtualizer for those that use Windows. Let me close this guy so I don't distract us. Right. So next step now is let us look at okay. So Hyper-V Manager is up, as you can see here. Hyper-V Manager is up. So once you have your Hyper-V Manager like this, all you have to do is to click Quick Create. My laptop is a little slow this night. I don't know why. All right. So once you click Quick Create, it brings up this this box for you, right? Then you can just choose. It gives you some of the operating systems. You can actually run any of these ones you want, but if you've already downloaded the CentOS, you can just choose the installation source. So you select local installation source. That will take you to your downloads folder, and then you can download an installation, and you can select the ISO. The ISO is like a disk that you connect, and then you use it to boot the OS. Alright. So you can see once I've clicked that, it takes me to my Windows machine. So it takes me to my file, to my document folder. I can go to downloads. That will be where my CentOS is downloaded. Right? Look at CentOS here. This CentOS here. I've already downloaded it before for the sake of this presentation. So this is CentOS. Once I press open, it will load it, and then all I have to do is click create virtual machine. That's all, and then it starts to create virtual machine for me. And that's really, you can see that if not my laptop is slow, we could have finished this process in less than 1 minute, right? But that's basically it. So let me stop sharing my screen. Presenter, please share your screen. You can see new virtual machine created. That's it, and you will have Linux running on your system, and you can practice with it. If you spoil something, you can delete it and create another one. That's how it become good. So presenter, please share my slides back. Are you there? Please help share my slides. Oh, you're having a small issue. Okay, that's fine. Let me share from here. Share entire screen. All right. Can you see my screen? All right, awesome. So I've also in this presentation I also added. All right, awesome. So in this presentation I've also added a Google Drive, where I've put together some of my best Linux resources. Some of these books were paid for, but you don't have to. If you don't report to the publisher, me too, I'll keep my mouth shut. So there are books I purchased earlier, but you can just download them for free. This is the link, right? I just copied it and put it in my Google Drive. So these are some of the Linux resources. Right. So you can see I have this interesting book, CompTIA Linux Plus. This one is a really good one. For some of you that are interested in the security aspect of Linux, there is this nice book called Linux Basics for Hackers. We have the Bash programming reference. As for people that will be going into Bash programming, or when as you're growing, you might start to see a use case for Bash programming. You can go through that book, go through some of the videos of that topic. I have this other book. There's another interesting one I wanted to tell you about. Yes, Troubleshooting CentOS. So this is also a good one for future administrators, future site reliability engineers. This is a good book. So I want you guys to take charge of these resources I've shared with you. Download them immediately. Keep them in a safe place, so that you don't misplace the link. There's also this one, the Linux Bible, right? It's also a really good one. It's not one that you finish reading. It's one that you reference to whenever you have a problem. You can always reference to it, right? So this link is available on the it's available on the group chat. It's available on the group on the slideshow that I've shared with your president. So please take advantage of these resources.